Hey guys, welcome back to the second podcast of our week 5, and we are getting into the very first, and believe it or not, most simplistic organic molecules called alkanes. Now, alkanes are a branch of organic chemistry where they are hydrocarbons. So ultimately, if you pull apart that word, it's made of hydro and carbon. And so it's any compound that contains only carbon and only hydrogen. And that's pretty logical. Now, don't get me wrong, there are variations of alkanes, but we are focused right now on the most simplistic one, which truly is just hydrogen, just carbon. And we call alkanes a saturated hydrocarbon. The meaning for that, if you even think about in terms of when we say something is saturated with water, it's got as much water in it as possible, while a saturated hydrocarbon doesn't have as much water, but it has as much hydrogen as possible attached onto it. How do you get more hydrogen attached to a carbon? Well, you keep single bonds. So key thing for an alkane is there are only single bonds between those carbons. So as long as you keep that in your brain, we're in pretty good shape. Now, in terms of naming alkanes, I'll introduce you to the first 4 of them. And you've already seen these a little bit because they've come up in some of the isomers that we were drawing. Now, the first 4 alkanes are methane, ethane, propane, and butane. Notice the specific beginning of each of those. In terms of what that coincides with, methane is C with 4 hydrogens. So it's a single carbon. Ethane, vice versa, is when we have carbon bonded to another carbon. So there's only 2 of them. When you put your hydrogens on there, we're going to have 3 on this one, 3 on this one. So that makes each carbon bonded 4 times. Perfect. Propane, I'm going to draw up above here. We have 3 carbons. 1, 2, 3. Remember, every carbon must be bonded 4 times, which means our middle carbon only has 2 hydrogens on it to make it saturated. Butane, we're just moving up in the chronological numbers. So we're at 4 carbons. 1, 2, 3, 4. And again, the ones on the end are going to have 3 hydrogens. 2 on the second one, 2 on the third, and of course 3 hydrogens on that last one. Those are our condensed structural formulas for each of those. Consider the molecular formulas for each of those. And I want you to look for a pattern here. Methane, well, it's exactly as it is, CH4. Ethane is C2H6. Propane, C3H8. And butane, C4H10. There's no doubt there's a pattern here. This is something I could have given you in elementary school and be like, okay, what's happening as you move on to each new iteration in the pattern? Okay, now the general formula that means for an alkane is this. C with N, meaning the number of carbons, and H will take 2 times the number of carbons and add 2. This is our general formula, totally worth memorizing because it can actually save you a lot of time as you continue with organic chemistry. There is a new definition here for you. Any set of molecules, and we're talking about in the realm of chemistry, when there's only one unit that it changes by as you move from the next to the next to the next, this is called a homologous series. Kind of a mathematical term, right? It means it's changing by the same thing as you move through from one to the other. In this case, we're adding a CH2 each time. Because of that homologous series, it makes making a general formula completely doable. All right, let's move on into the naming. Dun, 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 dun. So when you name an alkane, guys, we use the UPAC naming system, International Union of Pure and Applied Chemistry. It's the same naming system we've done that you've been introduced for chemistry for years now. And there's 3 main parts to it. The first part is the prefix, which we'll talk a little bit more of shortly. The next part is the root. And at the end, of course, is going to be our suffix. I was looking for an orange. That's kind of orange, okay? So prefix, root, suffix. Keep those in mind. Now, in terms of what we really focus on at this point is the root. And the root is all about the number of carbons in the parent chain. Now, the parent chain is going to be try to make it the longest chain of carbons that you can. So that's a key thing that I want you to focus on. Parent chain, try to make as long as possible. And that doesn't sound like a big deal, but when you start to see some of these interesting structures, and you'll notice you have to play around a little bit to get a true strongest length. All right, let's continue. Now, remember that prefix, root, and suffix that I was focused on here. In terms of what each thing is, these are really important for you to have straight in your head. A prefix is all about any branches, and we'll talk more about the branches momentarily. And that's always going to be given at the beginning of the name then. Going on into the root, I already mentioned this. This is all about that parent chain, that longest continuous length of carbons. And the suffix tells you what family that you're in. Now, in our case here, we're looking at alkanes. So the end of the word alkane, A-N-E, is the suffix. That tells you we are single bonded hydrogens. Now, there is a table that you need to take some time to memorize here. It's in your notes, of course, and it's pretty familiar because it's ones that we've been using for prefixes all the way through chemistry. The only exceptions here that feel a little bit weird are going to be meth. You haven't seen that before. So meth means 1. Eth is unfamiliar, 2, right? Meaning 2. And then prop is kind of weird, right? Prop meaning 3. And then going into bute. But after that, look at the familiarity of these. Pent for 5, hex for 6, hept 7, oct 8, non 9, dec 10. Those are all very familiar prefixes. These 4 are a little bit strange, and you'll have to get used to them. The good news is they come up quite often. You might just not have realized it was in reference to the number of carbons. For example, methane gas. Oh, you've probably heard of that before. Ethanol. Ethanol is a type of alcohol. It's actually an alcohol with 2 carbons. Propane. The stuff in our barbecues. Butane lighter. See, so that's what I mean. It's not that these are unfamiliar prefixes. You just might not have associated them before with the number of carbons. All right, let's get into creating some of these. What if we draw a condensed structural diagram for hexane? Okay. Now, if you consider that most simplistic, right? This is what we've done before. Condensed structural diagram. We're going to end up with, no big deal, 1, 2, 3, 4, 5, 6 carbons in a row. Okay. And how did I know that was 6? Well, I knew because of this, the root. That's hex meant 6. So there's little clues in the name that you have to pull from. How did I know that they were all single bonded to each other? Oh, well, that was because of this. I saw the ane. So hexane, we're good to go. We know it's 6 carbons joined in single bonds with each other. Put all your hydrogens in to make sure that you have the correct number. How are you going to know that you did this right? Well, if you want, you can use this to help you. CnH2n plus 2. If carbon has 6 of them based on the X, on the hex rather, then hydrogen is going to be 2 times 6, 12, plus 2, better be 14. Do a double check. 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Dun, da, da, da. You did it properly. It is always worth, with these drawings, guys, to really make sure you have everything on there that you're supposed to. It's very easy to make mistakes, forget a hydrogen, forget a carbon, etc. Double check, take the time, attention to detail. Now, in terms of how this is done, there's some definite steps that you need to take the time to memorize, to know, to understand. These are all outlined in your notes. But ultimately, we take that longest parent chain, right? That's our focus. And this is really important because you're going to have to number your carbons in order to correctly identify where side chains are, where branching occurs. So the longest parent chain is numbered, and you number it specifically to get to the branch the soonest. And when we show you examples, this will make more sense. So you always want the branching to start on the lowest number. Another word for these branches is a side chain. So you'll see the word side chain, branch, they mean the exact same thing. When you put branches on these hydrocarbons, like an alkane, they have a special name, alkyl group. Lots of new words, guys. So let's to clarify that, an alkyl group is a branch or a side chain on a hydrocarbon, such as alkanes. And a few of these common ones, and these are written out into your notes, we've got a 1 carbon side chain, a 2 carbon side chain, 3 carbon side chain, 4 carbon, and these would keep going, guys. But notice the endings on them. This is not just meth anymore, this is methyl. So the YL is how we show, and notice on alkyl, that's an alkyl group, okay? 2 carbon side chain, ethyl. Propyl for 3, butyl for 4. If we kept on going to 5, it would be pentyl. 6 is hexyl, 7 is heptyl. You get the idea. The list continues. Now, here's 2 examples that you've got in your notes. The biggest thing with this is you have to identify your parent chain, because that's going to figure out for you what the root is for the naming. And it'll also help you with the numbering. Show you what I mean from a numbering perspective. There's lots of ways we could number this first one, and you got to do it the right way. So here's one method. I could number this as carbon 1, 2, 3, and then I could go down here to 4. So those red numbers are one option. Okay, let's look at another option. 1, 2, 3, and I'm going to keep going. 4, 5. Ooh, that's better because I got to 5 carbons instead of to 3. Anytime you can get to a longer chain, that's what you want. So the red ones, nope, not as good. What if I go the other direction? Oh yeah, you got to think about this too, guys. You got to keep going. So what if I go this way and I start numbering 1, 2, 3, 4, and 5. Whew. Okay, my red numbers weren't as good. I only got to 4. So I'm going to get rid of those red ones. They just didn't help out as much. Okay, so now I've got blue and I've got green. I was like, oh, okay, which one? Well, look at which one gives us the lowest number for our branching. This is the branch off of it. And if I go from blue numbers, 3 is the lowest. If I go from green numbers, 3 is the lowest. Oh, here's the deal then. It doesn't matter. You could use blue or green. We get the exact same answer either way. Yay! Okay, now to actually do this, we need a prefix. Our side chain is single carbon, which makes it methyl. methyl. That's the prefix. My parent chain, I'll highlight it here, is like that. 5 carbons. That means that I'm going to have to use pent. Okay, there's no space. It goes right beside the methyl, but pent for 5. These are all single bonded carbons, so ANE at the end. Methyl pentane. One thing is missing. At this point, you don't know where that methyl is. You have to state it. It's a dash and put the number at the beginning. 3-methyl pentane. Look at each part. That pent is the root. That's what tells you it's a 5-carbon chain. The methyl is the side chain coming off of it, the CH3. The ane, I should also say that methyl then is what we call that prefix, right? That ane is my suffix. It tells me the organic family. This is an alkane. In terms of it being on carbon 3, that's where this came in, right? Okay, that's a condensed structural diagram. Look at B though. B is a line structural diagram, which again, don't lose sight. The hydrogens are still there. But when you look at this thing, we really have to identify the longest carbon chain. And we got to keep our number for the initial branching as low as possible. And let's start playing with numbering. Okay, starting from this side, I'm going to try it. 1, 2, 3, 4, 5, 6 is how many I got with my red numbers. All right, well, let's keep going and let's play with a green, and I'll go the other direction and see what happens. 1, 2, 3, 4, 5, and 6. Okay, and notice there's another way we could go. Now you got to watch this sort of thing, guys. What if I go down here? 1, 2, 3. If I go to the right, I get 4, 5. That's no good. 5 is less than 6. Don't even bother. 4, though, going this way. 5 and 6. Whew. Okay, check out those numbers. If I look at this thing, I'm trying to get my first branch to start at the lowest number possible. Start at the red. When I go with red, 4 is when I get to the first branch. Now I'm going to go green. When I go green, 3 is the first branch. That's way better than 4. So far, green is winning the race. When I go with blue, 3 is the first branch. Oh, so that means that the green and the blue are great. Either one works great. My red one, nope. Red, put the first number at number 4, not good enough. You can either imagine then your chain is being green or is blue. Just to make your brain think about it a little differently, I'm going to take the blue one. There we go. Okay, there's my parent chain. And that means that coming off of it right here is my branch, my side chain coming off. Okay, naming wise, have a look at this thing. Yellow has my 6 different carbons. So that means that it's going to be hex. Oh, I want black. Let's see here. There we go. Okay. So if I've got hex, because it's 6 carbons, they're all single bonded, so it's hexane. Coming off of there, 1, 2 carbon side chain. 2 carbons off is going to be eth. And it's not just eth because it's an alkyl group. It's ethyl, ethyl. Last thing we have to do is say where that thing is. It's on carbon number 3, so this is going to be 3-ethyl hexane. 3 is telling you where that side chain is located. So there's your prefix. Hex is telling you the parent chain has 6 carbons, and ane is telling that it is in the organic family of alkanes. 3-ethyl hexane. Lots of new stuff, guys. Alrighty, what if we go the other way? This was naming drawings, but how about if I give you a name, and I said, hey, now you got to draw this thing. Now, pay attention to what type of drawing I want for each of them. I want a condensed drawing for the first one and just a line for the second. And your assignment is going to be really specific to what type of drawing I want. So, like I said, pay attention. Same thing though, split this up into the prefix, the root, and the suffix, and you'll be pretty good. The parent chain is always a good starting point. Hex, you know you're going to have 6 carbons in that parent chain. It tells you that they're all single bonded, that's that ane, and then we're told, hey, there is a branching. There's a methyl group coming off. Where is it? Oh, it's off of carbon 2. So when you're drawing these, step 1 is make the parent chain. Like I said, 6 carbons. So start with that. Condensed, leave the room for your hydrogens. First carbon, leave a little space. Second, 3, 4, 5, 6. I literally count when I do these in my head to make sure I get enough of them. However you number them, you have to decide then where 2 is. And you can number going from left to right, or you can number going from right to left. I'm going to go from the right this time just to be a pain. That means that off of carbon 2, right, because of that 2, is a methyl group. Meth, meaning a single carbon. So I'm going to put it right off of here, carbon 2. Could I have started from the left side and put it instead right here? Well, of course I could have. It would be the same thing. Okay, so now we need our hydrogens in there. Anything on the end is going to have 3 hydrogens to make sure that carbon's bonded 4 times. Now we get to this carbon. I need 2 here, 2 here, 2 here. Be careful with this one. This one is already bonded 3 times, which means it only needs 1 more hydrogen to get it to be bonded 4 times. And then we got 1 on the end here again. H3. This bottom methyl group that came off also needs our 3 hydrogens. There it is, 2-methyl-hexane. Look at the next one. Line drawing. These ones are always fun. Methyl butane, guys. So check out this one. Once again, we know we have a 4-carbon parent chain. You can draw that right away. 1, 2, 3, 4, right? So there's our 4-carbon chain. And from there, we're told, hey, this has a branch coming off of it. That branch coming off of it is a methyl group. And we also know that they're all single bonded, which is all we've done so far. Now, this methyl group, it doesn't tell you where it is. Well, the reason why is consider where you could put it. If I put it here, oh, that's suddenly not butane anymore. You just made this pentane. That doesn't exist. No, can't go there. If I put it here, whoops, I did it again. I just made another pentane. No, that's not what's happening here. So now I have another option. I could put it there. Okay, cool. But really, is that any different than me putting it here? No. If you flip that thing, they're identical. So that's why there's no number in this one. No matter where you put it, this is still methyl butane. It's going to be coming off of carbon 2 regardless, so we're good to go. Keep that in your mind. These can be numbered different ways. 1, 2, 3, 4. Or I could number going the opposite way, like this, and number it 1, 2, 3, 4, and then put my methyl group off of this one. Carbon 2 no matter what. All right, guys, hopefully that feels okay. I know it's a lot to take in, a lot to consider. There are more questions that I want to do that talks about the different types of branching. I'm going to do that in the next podcast. So we're going to take a little bit of a break. That's the end of podcast 2. Our next part of alkanes will continue in podcast 3.